Okay, so what we're going to look at this topic is bivariate data. So bivariate means when we've got we have like two pieces, you might say two pieces of information. So two pieces of data from the one source. So what that means by that, like say for example, I could go around and collect your height and your weight. See, that was two pieces of data coming from the same individual. Does that make sense? Or we might, another one, we might work out, say, the population of the country and their birth rate. So that's two pieces of information coming from the same source, and then we had all the countries and things like that. So we're going to be investigating two, and you'll notice with bivariate data, and what we're going to be looking at is two numerical variables. So if you wanted to put, for example, there, the one I did. So for example, we might have collected your height and, what did I say? Weight. Yeah? So that's two numerical pieces of information. And we're going to use them and we're going to construct a scatter plot. So a scatter plot is where we'll have the two axes. So we have like the y and the x. And so what you're going to do is you're going to put those two variables on one on each of the axes. So say for height and weight, I'm going to help you out here. We're going to say we'll put the weight as your y value, and we'll put your height as your x value. And say we were doing all of this class, so we'll see, say, all these dots everywhere. And obviously, as someone's height goes up, you would expect their weight, yeah? They're going to weigh more if someone's taller, and so we would expect those dots to go up on an upward line. Okay, so what we call those two variables, so we have two variables. One is called the explanatory and one is called the response. So to help you out, the explanatory one, see how it has the x in it? So that one goes on the x-axis. Okay, so it's got the x in it, so the explanatory variable will go on the x-axis, and the response variable will go on the y-axis. Okay? Now, we need to know the difference. So what the explanatory variable is, it's used to explain, or then we sometimes say predict the value of the response. So what the response one is, and you might want to write like this in brackets. So the response one is like the one you're investigating, one that's being investigated generally. And so if you had a look, if we were looking at, say, the height and weight, I might go, and what I would be looking at is, see the explanatory, so the height. So I'll look at your height, but we'll be weighing you, and we're seeing how much you weigh. I want to see, does your height change your weight, okay? So this is the way we've got to work out, because sometimes we're going to get given an example and it's crucial that we get them on the right axes and that we know which one's which. So let's have a look here. It says, we wish to investigate the question, do older people sleep less? Okay, so that was their little investigation. So they've gone out and they've collected the two variables. So the two variables that they've collected is age and time spent sleeping. Okay, so which is the response and which is the explanatory? So they want to know how much people sleep, their time sleeping. So which one are they investigating? The sleep time. So which one would be the response variable? They're investigating the sleep time. Yeah. So you'll know that this one's the response variable. And sometimes underneath you just, when you're reading it, they might not always ask this question, but we're going to say that. And age is explanatory. So if we write that out here, so we're going to say age equals the explanatory. Now, in God, I think I spelled that wrong. Explanatory variable. Now, in other sciences, your explanatory variable is sometimes known as, have you heard of it as the independent? Yeah. Have you heard of that? Yeah. So in maths, they're just being difficult. I don't know why. It's just in general maths. Everywhere else, they'll call it the independent variable. And you would have seen that. Now, independent means it can't be influenced by the other. So can your age change for any other reason? No, it can't, can it? So, but could the amount of time that you spend depend on your age? Yes? So the other one, so we often call the other one in other sciences. So we said that time spent sleeping was the response variable, but so we'll write that. So in our maths, we're going to call it the response variable. But in your other sciences and in the general reporting, you often hear this as the dependent variable. Okay? So if you do any of those sciences, you'll hear about that. So if you go back to my one up there, height and weight, there is nothing you can do about your height. You are going to be the height that you're going to be, aren't you? So this one is actually going to be the, this one would be the independent. So this would be the explanatory variable. You can't change your height. Just because I suddenly put a lot of weight on is not going to shoot me up higher, is it? No. So height is explanatory, it's independent. But weight, yes. If someone is taller, weight will change and can change. So that one is the response variable up there. All right. Let's give this next one a go. We wish to investigate the association between kilojoule consumption and weight loss. So there's two numerical numbers. You're going to count how many kilojoules you eat, and then they're going to see the weight loss, maybe in kilograms. So they've told us there, the variables are that, kilojoule consumption and weight loss. Which is the response and which is the explanatory? Which one do you think people would be investigating? What do we want to look at? Weight loss. So if I said that's the one we're probably investigating, what did I say? Which one was the investigating one? RV, good. So that one's RV, and that makes this one EV. So there you go. You don't need to write it out. You can just write it underneath. So the explanatory variable was kilojoule consumption, and the RV was weight loss. Okay, let's look at the next one. Okay, so this one, example 3, we can predict a person's height. So this one's, because sometimes they can be a little bit tricky, but we just got the word, we can predict a person's height from their wrist circumference. So the two variables is height and wrist circumference, both numerical, so they're going to be like centimeters. But which is the response? Remember when I said you will see the word predict or investigate on which one? The response. So if they said we're going to predict a person's height, which one's our response variable? Is height. Okay? So height equals the response. So if you want to make a note, that word predict will go with a response variable. So whatever you're predicting is a response variable. And the wrist circumference. So, because sometimes you can't, they're not logic, or, you know, it could go either way. And when it can go either way, they need to tell you. So they've told me with this one, because really my wrist circumference probably is not going to change either as much as my height is. It's probably both predetermined. So they're going to tell you. They're saying we want to predict someone's height from it. So wrist circumference was the explanatory variable. All right, so if it's hard, or you think, oh, that could be either way, then they're going to tell you in some way. So let's have another one. A teacher is concerned that her students are tired in class. She suspects it is because they spend too much time on social media when they should be sleeping. The variables in this investigation are amount of sleep and time on social media. Which is the response variable and which is the thing? So which one do you think we're measuring? Yeah, good. The measure of sleep. Yeah. So amount of sleep is RV. And time on social media is EV. So it's really important to know which one's the RV and which one's the EV, because we are now going to draw a scatter plot when we get this data. And as I said, the RV is going to go on your y-axis and your EV is going to go on your x-axis. And it won't work, and it's crucial that you will get the right way. Otherwise you'll get wrong answers for other things. Okay? So if we have a look at this one, it says they looked at students, and they had 10 students, and they looked at the time they spent studying and the mark they got, the percentage marks, all right? So this response, they would have been looking at what they got as a score, and their explanatory was their time spent. So when you're actually creating a scatter plot, all you're doing is it's like this becomes a point, and you can see that there. So the next one, the student 2, I would go up to 36 hours, and they got an 87. So say they'd be somewhere like up here, and there would be my next dot, okay? So we'll roughly do it. So there's that one. That's student 2. The next one was 2367. So maybe I'm just making these up, like roughly. Let's do that one. 19 and 62. Maybe there. 1 hour and 23. That's probably Tyson's. Joking. 11 and 52.
Oh, this sounds funny.
18 and 61. 13 and 43. 18 and 65. So there was 2 people who studied for 18. Sorry, there's a few dots there. And 8 and 52. So there's roughly, because we have 10 students, we've got 10 dots on there. And that is a scatter plot. And what we will eventually work out in doing is we will look at creating a line of best fit, and we'll do this later on, and this is where we end up. And so we end up getting this prediction line, and that's where the topic before is going to help us, because we've looked at a few of that. But anyway, that is a scatter plot. So obviously that's manually doing it, and it's good to know exactly how they're formed. We're going to use our calculator mainly to construct scatter plots. But anyway, let's have a look and see if we can interpret this scatter plot already done. So the scatter plot shown has been constructed from the data to investigate the association between price and the age of the car. So you can see age would be explanatory and price would be response. Okay, so that was the first question. How many cars are in the data set? So how many things did they investigate? How are you going to work that out? How many cars were in this investigation? Why is it 12? There's 12 dots, so there was 12 cars, okay? So that's how we got that. Good. 12 cars because there's 12 dots. Okay, how old is the car circled? Up here. So what was it?
6 years old.
Yeah, good. It's a 6-year-old. And what is its price?
$12,000.
Yes, good. So it's on 12, but the units on the y-axis are saying it's 1,000. So it's $12,000. Good. Okay, so now we're going to look at drawing a scatter plot, and here's before was the data that we had with our students. So we're going to do this on the calculator. The instructions are there. I'm going to stop this video and we're going to do it with the calculator app.